Hello everyone, I am Dr. Pritika Bahar from Department of Artificial Intelligence and Data Science. I welcome you all to Prestige Institute of Engineering Management and Research online lecture series. As a part of AD-801 Big Data course, today we are going to discuss about the summary of Unit 1. The first topic that we have discussed during the lectures is what is big data. So big data refers to the large and complex data that are difficult to be processed using traditional data processing tools. Big data is critical for decision making and it is utilized in various domains, including businesses, healthcare, finance, and government. The characteristics associated with big data include volume, that is size, velocity, that represents the speed of the data, variety, the different formats of the data, veracity, the reliability and accuracy of data, and value, the usefulness of data in deriving insights and making decisions. On the basis of sources from which the data is generated, it is generated by persons, humans, so it is human source data. It is generated from digital devices, so these are the machine generated data. Another set of data that is generated from traditional processing is considered as structured format data. On the basis of whether the big data is having a structure or schema associated with it, we can classify it as structured, semi structured, and unstructured data. Let's now compare how traditional data is different from big data. The traditional data size varies from small to medium, whereas big data is massive in size. When it comes to traditional data, it is mostly structured, whereas big data may be structured, semi structured, or unstructured. When it comes to the processing speed, most of the time the traditional data can be processed in batch format, whereas in case of big data, we need real time or near real time processing. Traditional data is having a specific schema and hence it can be stored in relational databases, whereas big data needs specifically different data formats to be stored. It may be NoSQL or new SQL formats. So distributed file system is needed to store big data. Traditional database have limited scalability, whereas big data is highly scalable and it can be stored using cloud and distributed system. Next, we have discussed about evolution of big data, in which we have considered that in the early age of data processing, we are having electronic data processing, information system or management information system. As the data sizes grows over the time, ERP come into picture, that is enterprise resource processing. Then comes the internet age. At the time the data is processed at a complex level. Then also it is having terabytes of data and that is considered as web data. Nowadays we are having modern data, big data edge, in which we are having advanced analytics. We need real time processing and the data may have structured or unstructured data format. Let's start with what are the challenges faced with big data. The first and foremost challenge that one faces while managing big data is how to store the massive data volumes efficiently. Another point is data quality and cleaning, that is ensuring that the data that we are collecting is accurate and reliable one. Security and privacy represents that how to protect sensitive data from breaches. Processing and analysis of data is important as we want to extract meaningful insights from vast data set. Integration is also a challenge because when the data is generated, it may be generated from multiple sources. So to come up with a simple format or a single format, it's quite difficult. Let's move ahead with what are the technologies available for big data. Several technology support is available for big data processing and analytics. For a storage solution, we can use HDFS Amazon or Google Bigtable. For processing, we can utilize Hadoop, Spark or Flink. Database technology include NoSQL databases and new SQL databases. Cloud platforms can be utilized for proper storage of big data. Analytics and machine learning, we are having TensorFlow, Apache Mahout, and Scikit-learn. Next, moving ahead with what are the infrastructure requirements for big data. So when it comes to infrastructure requirement of big data, it needs storage system that must be distributed over the cloud edge. Processing unit, high performance computing clusters are needed. Networking components are required for high speed data transfer. Security measures must be there so as to secure our sensitive data. The next point that we have discussed during the course is what is data analytics. Data analytics helps in extracting insights from big data, and it is categorized in four major categories as descriptive analytics, which summarizes the historical data. Diagnostic analytics explores reason for past outcome. Predictive analytics deals with statistical model to forecast future trend. Prescriptive analytics suggests action based on data insights. So basically descriptive and diagnostic analytics looks for the past, whereas predictive and prescriptive analytics looks for the future. The last topic that we have discussed during the course is what are the desired properties for a big data system. So if you are planning for a big data system to be built at your end, it should have the scalability, it should be capable to handle growing data loads, it must have fault tolerance property, it should be highly available, that is ensuring continuous access of data. It must support different data types and sources, that is flexibility. When it comes to the big data, protecting data while adhering to regulation is important. So security and compliance is also needed. Efficient resource utilization to minimize expenses, that is a big data system is considered a good one if it is cost effective. We will discuss about unit 2 of our syllabus, that is based on Hadoop, which is an open source platform for storage and analysis of big data. Thank you all.